Gesture-based home automation using Arduino Nano. This is the 13th tutorial of practice project for PCB designers. Welcome back to Linked Frequency. I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. In this tutorial, we are going to learn about how to interface this gesture sensor module with the development board like Arduino Nano and control the home appliances. This is again a practical project and a real life example with respect to understanding how to control the home appliances or maybe any AC appliances by using a hand gestures. So let's dive into the black box analysis. Here we have a black box analysis. First thing, we will be having a AC 230 volt 50 Hz input because we are controlling the AC appliances, so that we will be having a AC input for our entire DC system. That's why we are going to convert that AC into a DC by using a AC to DC power supply converter, which is obviously for a 5 volt per conversion because our entire electronic circuits works on the DC 5 volt. And then we will be having a main controlling unit, which is a development board or maybe a controller as per our requirement to control or process the algorithm that we want to execute based on the gesture. And of course, we will be having a gesture sensor which will recognize our hand gesture with a certain distance or maybe a certain patterns. And then we will be having a 5 volt 2-channel relay module which is helpful for controlling the appliances as per the requirement. Thereafter, we will be having a one user interfacing module which will be helpful for the user to recognize what is happening inside the system or maybe to set up a certain conditions for the hand gesture by using a buttons or maybe a buzzer or maybe a display. This is all about our black box analysis. I hope you understood, and it is exactly same as our previous project, but only the thing is different sensor, different actuator, different application altogether. Now we have a white box analysis in front of us. The AC input is 230 volt 50 Hz. That's why we will be using a high link power supply, which is a PCB mount power supply, very compact one, very widely used in industrial application, which converts a 230 volt AC into a 5 volt DC. Part number is HLK5M05, which is a 5 volt 1 ampere SMPS module, which sits on the PCB. That's why we are selecting that one. And then we will be using a development board called Arduino Nano V3. This is very common, very easy to use and very generic for the DIY segment. And for our design activity, for practicing our project design, this is one of the best suitable. And then we have a motion sensor or gesture sensor, which is all about APDS 9960 module. This particular sensor recognizes the hand gestures in front of it. Thereafter, we have a 5 volt DC relay module, which is a SRD05 VDC. Notice this is the same relay module that we designed in our previous tutorial. We are going to copy paste them as we did in our previous tutorial. And then we have a 16x2 LCD module and a buzzer to indicate what is happening inside the system or give a buzzer if anything goes wrong, or if you want to integrate a sound system or maybe just indicating a beeps whenever some gesture is recognized. These all details are displayed on the LCD, as well as buzzer is used for displaying or creating a sound effect to understand what is happening inside the system. This is all about our white box analysis. Now we'll jump into the easyEDA to start a design activity. Here we have on the easyEDA, now you can go to the file and create a start project and click on the new project. I'll keep my repository as my personal repository. No description at this point of time, so I'll just start. Now let's start with the design activity by using an easyEDA as we always do with the fast forward way. Alright, now you can see that this is the schematic for our white box analysis, that is gesture controlled home automation system. As you can notice here, the HLK5M05 is the only power supply. There is no need of a 5 volt power supply or 12 volt power supply because it gives us a 5 volt directly, a DC 5 volt. And we have our Arduino Nano development board and then these modules which we are using in this entire system. That's why you can see here the power supply is very small and very tiny, but the footprint wise, this is the biggest one. And then APDS module is with us and we have our Arduino Nano. I think I have missed adding this buzzer pin to our circuit. So let me add it here because there is a little small space. I mean, I cannot make it a little long. So that's why I'll keep it here. And other than those pins, whichever are not used in our circuit or maybe a design, we have to make them a no connection flag. Otherwise, the system will, produce a ERC error, which is also called as electrical rule check error. So that's why you need to make sure that you add a no connection flag where the pins are not used. And when it comes to I2C LCD, I have used I2C LCD, not the normal one LCD, because normal one LCD will be very complicated with a lot of circuitry and all that thing. So that's why we have used I2C LCD. And for that, we need to add only SDA and SCL pin, which is available on the A4 and A5 pin of the Arduino Nano development board. And buzzer pin is very straightforward, digital one, and relay 1 and relay 2 are the straightforward one. This circuit, I hope you have noticed it. I literally copied this entire complex circuit from my previous project. That is the beauty of our EDA tool, that is easyEDA. You just need to copy and paste it in your new project and it comes. Very simple and straightforward. So this is all about our schematic. Let's jump into the PCB layout and start designing the PCB. Alright, now you can see that our design is completed. There are a couple of things which are very special to learn in this entire tutorial, which we are going to discuss now. The first thing is all about this entire system is designed in single layer PCB. And you can notice that the way how we designed a 2-layer PCB or 2-channel relay module, whatever the PCB design we did for a 2-channel relay module, we followed the exact same standards, the same IPC process for this design as well. The only thing left is this text layer, adding a text to all these connectors and all, which I have left it purposefully because the video is going too long. That's why you can add that particular thing, AC, phase and neutral here, and this is a COM pin, NO, NC and all that thing you can add here. And you can also add our design name also. This is all about gesture controlled the home automation system. So I will be adding a linked frequency _ okay. So you can add the entire project name and your name in the entire system. Okay. So this is all about the entire gesture control based system for home automation here, where we can control 2 appliances based on the gesture symbol or a hand gesture recognized by this sensor. We have created it with 3 jumper wires. 1 is here, 2 are here. If it is possible for you to solve this problem and create it without using a jumper, then give a try. Of course, it is possible. Why? Because it's not that complicated circuit. However, because of this particular video, I don't want to make it too complicated. That's why I made it very quickly to avoid the complications in the entire video tutorial. But you can still do it. One thing we have to learn, or we learned in this, is we are isolated our digital ground with the analog ground. There is no analog ground in this. There is no earthing in this, because it's very difficult topic or a very different topic to discuss in this particular tutorial. It is not possible. That's why we have removed our ground section, or I have created only ground section for the digital section, not for the analog input, which is AC input. And we created this particular partition here. And this partition is very essential to avoid the problem with respect to AC and DC circuit. If anything goes wrong with respect to this AC signal or AC copper, or if any AC copper get connected with the DC ground and all, the entire digital circuit will be burnt in a microsecond. We'll not be able to even recognize it also. Okay, so that's why we have to remove that particular partition, or we have to create this partition to avoid the uncertain event with respect to AC and DC circuit. And of course, on that particular time, we have to remove the ground connection with this mounting pad as well. Make it not connected to anything. That is also possible. It doesn't make any difference to us. It's just a mechanical mounting. However, we have a 3 ground connection here, which helps us to connect the entire PCB with respect to ground pin, and helpful for the mounting on the casing as well. So if I go to the 2D diagram and a 3D diagram, you can see it like this. You can also notice that the buzzer is also kept inside this Node MCU module, not Node MCU, Arduino Nano development board, because it is possible. You have a very good space over there, and you can literally place the components inside other component if there is a good enough amount of space over there. Right now, in this case, it is not showing a space because its 3D model is not so good one. But in reality, you will get the very good enough amount of space here where you can place the buzzer inside. And if you place a buzzer over there, then only this PCB becomes such a compact one. Otherwise, you can place a buzzer on the other side and make it a little larger one, which is not recommended because the cost of PCB will increase and the design looks a little bulkier. However, this is looking very awesome, and it's really looking like a true product, and you can literally use this product as a real-time design as well, because gesture sensor is exposed to the hand gesture sensing, and I2C LCD pin is given very sufficiently with the space, and Arduino Nano cable is, the USB segment is at the border side, so that you can literally connect it and program it at any point of time. So this is all about our gesture sensor based home automation using Arduino Nano. I hope you enjoyed the entire tutorial. I believe that you are going to design it by yourself and learn it by yourself. If you get any doubts in the process of designing this one, feel free to ask me in the comment section. I'm very helpful and I'm very happy to answer your question at any point of time. Thank you so much for watching the video. Consider subscribing to our channel Linked Frequency to get a more notification and such kind of a tutorials for learning. See you again in the next video. Until then, bye bye. Tune yourself to make a difference.